so let's give him a big round of applause.
All right, so my name is Hollar. I have been a professional software engineer for a while. I was a senior software developer at Rosetta Stone for almost 9 years total. I worked for Rosetta Stone when it was 40 people. And then I went back after school and there were about 600, and by the time I left there were about 3,000. From there I went to a small startup in Boulder, where I was an engineering director as well as a contributor to many of our different code bases. And now my title is Director of Mobile Engineering for a small startup out of Ann Arbor, Michigan, where I just got back day before yesterday from, where I'm in charge of sort of platform design stuff as well as client side and iPhone development. I've been hosting the Boulder iOS meetup for about 3 years now. We're a really good group. We usually get anywhere from 35 to 60 people per month. We meet on the last Tuesdays of the month at Galvanize in Boulder. And it's a really great group for people that are interested. It's definitely beginnerish. Sort of depends on what the individual speaker is talking about, but it's a good time. Like, it's not a hardcore Cocoa Heads meetup, which they do exist, but not in Boulder. Those are in Denver. So today, we're going to use Xcode and Playgrounds to learn about the Swift programming language. We'll go through 2 playgrounds. I'll talk a little bit, I'll introduce a concept, and then you guys will read about it in the playground, look at some examples, and then start writing code. For those of you, all right, who has never like coded before? All right, all right. If you have coded before and you find yourself relatively bored, listening to me, which is theoretically possible, go fast. At the end of the second playground, there are a whole bunch of links to lots of other things that you can read and tutorials that you can play with if you're a bit handy. Because I mean, I really want I want the pace of today to sort of not leave anybody behind if I can help it. So by all means, go forward. If I've stopped and I'm walking around helping people and you have a question about something in the future, I can help with that. Great. The last part of this, I've built a playground that has a majority of the logic that you'll need to figure the rest of the way out and then move into a skeleton of an iPhone application that we'll see. We'll get a little preview of that at the end of the second hour, and then you guys will finish that up and you'll have written your first iPhone application. Did everybody get the Swift zip file? All right. What else? Yeah, oh, and I mean, to second Tom's point, please, any feedback that you have about the course or about how great I did or whatever else, we'd really like to hear it. This is the first time we're going through this particular course in this format with an awful lot of people. So if you think you're nervous, it's okay. So please, any sort of feedback. Like there's a lot of ordering questions I wasn't sure about. Like code completion is a big feature, but maybe it's kind of confusing. I don't even mention it for another like 86 slides, which is not true. But I don't mention it for a while. And like, I don't know if that was the right choice, but we'll find out. So first, let's talk a little bit about programmers and what it is to be a programmer, in my very humble opinion. First off, confidence. I had a professor in school, and this has stuck with me for a really long time, that 90% of computer programming is the confidence that you can solve the problem. The other 10% is contained in books. I mean, I very much believe in this. Like I've taught myself like iOS development and OS X development like by hand, just by reading, which brings me to my next point. We're always learning new things. Things are always changing. Like Swift came out less than a year ago. Before that, every time Apple releases a new iPhone OS or a new operating system for their desktop hardware, you know, we've got to sit down and read all that sort of stuff. Like maybe we just have to learn a couple new frameworks, but you can never tell. But I will give you this advice. And this is another thing that has sort of stuck with me for a long time. Read 3 books. If you're trying to learn a programming language, read 3 books. Because the first one will make almost no sense, especially if it's one of the first languages that you're reading. The second one, things will sort of start coming together, and maybe you'll remember. But by the time you get to the end of the third book, you'll have heard the same stuff from 3 different perspectives, hopefully, in slightly different order, and you should have enough context, hopefully, to sort of take that forward and go. Programmers are generally very communal if that doesn't involve meeting in person and talking to real people, but on the internet. Stack Overflow is a really good example of this, like a great resource for us to contribute and help each other without the awkwardness of like pants. We're also really good at Googling things. I've noticed like a senior software developer can Google so much better than a junior software developer. It's wacky, so get good at that. Other things I'd mention, let's see. Oh yeah, no, wait, I lied. There are physical communities as well. The meetups are a really good example. This is a good example. Yeah, all right, so. So, as I said, Swift is a new programming language. It was developed, I can't remember exactly, 3 or 4 years ago, and Apple released it to us last summer at WWDC, which is their big developers conference that they have every summer. It is still changing. The language is changing. I've seen features get added with all the releases over the past few months. Xcode is still changing with the way that it does playgrounds. There is at least one thing in today's playgrounds that probably won't work, and I swear worked yesterday. And I do not know why it doesn't work today, and I didn't have time to figure it out. But it's called out as such in the playground, so hopefully that won't throw us. When I started learning Swift, there was really nothing available besides what Apple had put out, which is a really good document, and their developer blogs. Now there's lots and lots and lots of stuff out there, and there's more every day. A lot of the tutorials I linked to at the end of part 2 are Ray Wenderlynch, who has been going overboard doing this stuff, and a really good place to check out. All right, enough chitter chatter. So if you haven't already, please open the file 1_Swift something introduction.playground. And at the top there, you should see a line that looks like this. Your colors might be a little bit different, but can everybody open that file? Can anybody not open that file is a better question. All right, fantastic. Cool, so Apple's made a really big deal that Swift, and in particular playgrounds, should be used for education, and they've really encouraged like us, people that are teaching other people to program, to do so. So what happened when you change this line of code? No, one at a time, please. Ooh, maybe. Can I anymore? They changed the way this works in Yosemite. Sorry, so at the top of, no, I can't make this bigger. So at the top of this file, there's a line that says print line and hello world. Maybe I will just, all right, so this over here on the right-hand side changes. That's what's so really, really neat about playgrounds in conjunction with Swift. As soon as you guys start editing and modifying code, give it a second or 2 or more, depending on how old your computer is, and it should update out here. One thing to note is that all of the sections that are inside, all these coding sections, need to be correct. And we haven't talked about what that means yet, but if you make a mistake and you break basically the syntax of the program, the whole thing will break. So you got to be careful and make sure that each one of these guys is correct. From this point in time, though, so we at least made it that far. Great. The way this playground is set up, there's sort of long form text describing whatever the principle is that we're going to discuss, and then I have a look block in blue. Under that is a piece of live code that you should mess with. Change the parameters, try to make it do something a little bit different. Try to understand like what that is trying to communicate. Then, because we don't always write perfect code, there's a block for you to fix. So there's some things that are wrong. Inside these fix blocks, you'll have to uncomment the broken code and then fix it. And once again, if you leave it broken, then all of the rest of the code examples will be broken, which is one little drawback to playgrounds, perhaps. And then last but not least, you'll be given criteria and asked to write a small snippet of code that does a particular thing. What's great about playgrounds is that you can do these sorts of operations in such total, like in such isolation. Typically before this, if we wanted to play with something or if we wanted to learn with something, you have to build a whole new app. So you wanted to see what the new shadow effects look like. So you got to build an app and you got to put a button on it. And when you push the button, then the shadow changes. And if it doesn't work, you got to turn it off and then you got to change the code and then you rebuild it. And it's this whole big long cycle, which is considerably shorter than years ago when compilers took a really long time. But this sort of instant feedback and hopefully giving you guys very small concepts and asking you only to play with those and then building upon the foundations will be a good way to execute this. There's some syntax that I won't sit here and read to you, but I would encourage you to do so. So let's talk about some of the things that we will go through. All right, so there's two programming languages allow you generally to store variables and constants. Variables are things that change, so the speed of a car, the coolness of the visor I wore today. These things are not always the same. And then there's things that are constants. Pi is a constant. The number of wheels on your car is a constant, hopefully. So the reason that we care about this in programming language is that constants are a lot cheaper since they don't change. And so we should try to make as many things constants as possible. Every constant and every variable has a specific type. These types are fairly close to things that that we use, especially if you remember some of your high school math. Integers are whole numbers that can be positive or negative, but they don't have a decimal point. Floating point numbers do have a decimal point. Booleans are true and false, and no other thing. And strings are a collection of characters. In Swift, they're denoted by double quotes on each side. So when you changed what was read on my slide, that hello world text, we would say you were modifying a string. And comments. There's a way inside, I guess, every programming language to leave comments, which are just, words that help the programmer or people that come after the original programmer understand what is going on. For me personally, I tend to be a comment-first programmer. So I will write all the comments out for what it is I'm trying to do, and then I'll go back and I'll write the code. It's like when we teach the real Swift class, we'll teach you how to do things like that, maybe even with paper. Because paper is nice and slow, and it almost never crashes. So that's good stuff. All right, so with that in mind, go crazy. Complete up to write number 1, which would be the first 3 look, fix, and write blocks. If you get really stuck, raise your hand. I'll come around, help your neighbors. They might be nice people. All right. I see a bunch of people have started on the second one, so I will keep going. This will be pretty short jaunts. Like I'll talk for a couple minutes, you guys will code, you'll get stuck, you'll get help, it'll be great. So, math. Math's good. Computers do math. Computers do math real fast. That's super helpful. The first 4 of these aren't, hopefully you don't need too much of my help to figure out the first 4. The last one, modulus, is a little bit weird. If you've used other programming languages, then you probably know about this, otherwise you don't. So we talked about integers or whole numbers and floating points have variables, have decimal. When you're doing integer division, so what's 10 divided by 2? Quick. All right, great. What's 11 divided by 2? In integers. I mean, it seems like that's not the whole picture though, right? Like back in elementary school, we learned how to do division and then we had that whole number thingy and then we had the remainder, right? Modulus is the remainder. So there's one of the easiest ways, one of the best examples of this is you can use modulus to determine whether or not a number is even or odd. So any number that divides against 2 without a remainder is right. Good times. And I think that example is in the code. Comparisons. Comparisons allow us to start to like do things and make decisions. These are pretty, once again, like hopefully these are symbols that you remember from algebra or something. Greater than, or left-facing Pac-Man as I like to call it. Right-facing Pac-Man, or the less than sign. Equals. So equality is 2 equal signs, whereas assignment is 1 equal sign. And then greater than or equal to, as well as there is a less than or equal to. And those are your comparison operators. Everybody get that? Cool, cool. And then in section 2, we start getting into if statements. These statements have, so once again, like we're starting to look at like how we make decisions. So as the code executes from the top to the bottom, we get to a point where we check something and we say, well, if this thing is a true thing, and we can do this in any sort of statement. So we could say, if this value is greater than that value, then do this. If the pressure inside the boiler is greater than the maximum allowed pressure, then open the relief valve. Otherwise, everything's all good. Print out, go to party, whatever. So an if statement allows us to make one check and do one thing. An if else statement, we make a check, we do one thing. If that check is false, we always do another thing. And then there's another style of statement, the if else if statement, where you can check a whole bunch of different, and you can put as many else if statements as you want. So we can check a bunch of different things with this mechanism and then have one fall through case where it always executes or not. Like you don't have to have this final else statement. So you could say, if boiler pressure is greater than maximum allowed, do this. If it's less than minimum allowed, do this. Otherwise, whatever. Like we don't care. If everything's happy and normal, we'll just leave it alone. You could think about this like in your car, right? If the oil pressure is too high, do this. But like my car doesn't do anything. It doesn't warn me that like I have enough washer fluid. So we just ignore that case. So if else statements. Cool. Questions on that before I let you go again? All right. So go to 2. Oh, I lied. Go to 2 and 3. All right. Excellent. Oh, this one's only one slide, so I won't talk for long. Lucky you. So the next section talks about logical operators. So we've learned how to like make really simple decisions a little bit, like if something equals something or something is greater than something. But a lot of times you'd want to combine these things or say, so the first logical operator is not. So not takes true and it makes it false. So you can say if, like if you're, why can't I think of a good not example? Well, anyway, it turns true into false. And you can just change like a single expression and flip it, or you could flip something inside of a parenthetical expression and flip the whole thing. The next one is and. And means that both things have to be true. A nice thing about Swift, like a lot of other programming languages, is, and I can't remember the term for it, but if the first expression is false, then it will not evaluate the second expression. So that's good to know. It shouldn't really come into play today, but it's a good language feature. So a lot of times your first check will be something that it verifies that if you do this, or rather, So let's say this is this object, can I use this object? And this one is pull something out of that object. And if you call this where that would be false, this would crash. So we use it for that a lot. Or this or that has to be true. It doesn't matter which one is true. If the first one is true, the second one is not evaluated. And then, like I said, you can combine things with parentheses. So true and true is. And with the parentheses, now we have true on the left side of the expression, or false. True or false is true. No, true or false is in fact true. And true and not false. So not false is true. And so true and true is equal to true. So there you go. Logical stuff. Couple of lines. So a couple of you guys either figured this out by skipping ahead or by, or you asked. So I think all the examples up to the fifth part, it's doing like addition. So we take what we call a string literal, and then we add a valuable or a constant string to it, and it literally adds the two things together, like that Sesame Street thing. There's also a fancy mechanism called string interpolation, where you can embed the string. So these two statements are exactly identical. It's just a lot cleaner a lot of times to write the code inside the string. Like if you had a whole bunch of these things, then you wouldn't have all these plus signs and extra spaces around it. You can do operations and sort of whatever you want, whatever is returned will do. So you could do math inside these parentheses if you so desired. That might make it hard to debug. I'm not sure I would recommend it.
It's just a single expression.
Yeah, but I mean you could,
And the loops, nothing like that.
yeah, that probably wouldn't work. You should, and that would be really hard to read and not a good idea. There's a whole lot of different looping structures in Swift. If you've used other programming languages, the loops that you know and love in those are present in Swift. Maybe even some more, or some ones you might not be aware of. I'm only going to discuss one today, and it's called the for in loop. After the break, we'll see how this can be a lot more useful, but for right now, we'll talk about the range operator, which if you know Ruby, like it has this, and I was very happy to see it come in to Appletown. So what this says is, you know, give me a constant value for each one of the numbers between 1 and 3, including 1 and 3. So what numbers are those? Sharp. Right. So this will print to the screen 1, then it'll print 2, then it'll print 3. Right, just like that says. There's a second operator, which I'm sorry, this is the dumbest looking operator in computer science. The ... less than sign. This will only count from 1 to 2. So it'll start at the left, it'll count all the way up to the number that is less than the one on the right hand side. If you've programmed before, you've probably written a for loop where you said, for I equals 0, I less than whatever dot length. This gives you that mechanism conveniently in a range operator. It's called out in the playground that even though I'm using integer literals here, variables work as well. So this could be a variable or a constant as opposed to the literal number 1. A bunch of you guys figured this out as well. The quick view and the value history. Over on the right hand side, I'm sorry if this is kind of hard to see, but if you hover over a line of code, you can click on the eyeball, which is the quick look button. And for the things we've done so far, there's not very much to quick look at. After the break, that'll change. And then the white circle is value history. It's the one all the way over on the right hand side. And so you should click on this This will let you track a value on a chart, which is pretty cool, but it'll also show you the console, which is the output of all of your print line statements that you've made so far. All right, so with that in mind, we're definitely at our break time. So I'd say let's take a break. We'll come back, give you a few more minutes to finish up part 1, and then we'll pick up on part 2.